Hello guys, welcome to my YouTube channel Algorithm Avenue. This is our third video of the deep learning playlist. In this video, we'll be covering three topics, that is definition of deep learning and machine learning versus deep learning. And our third section will be why is deep learning in a boom in this period. Okay, let's continue with our first section. Okay, in the first section, let's see definition of deep learning. Deep learning is a subfield of artificial intelligence and machine learning that is inspired by the structure of human brain. Deep learning algorithms attempt to draw similar conclusions as humans by analyzing data with a given logical structure called neural networks. So, we'll be dividing this into subparts and we'll understand the definition in detail. Okay, first, deep learning is a subfield of artificial intelligence and machine learning that is inspired by the structure of human brain. Okay, first let's see a diagram to understand this. Okay, we have three different structures here, means three different ovals. In this three different ovals, first will be our artificial intelligence. Machine learning is this, if artificial intelligence is this structure, then machine learning is a subpart of the artificial intelligence. Means this is machine learning. Deep learning is a subpart of artificial intelligence and machine learning. Now, this will be the deep learning. So, deep learning is a subfield of artificial intelligence and machine learning. This is inspired by the structure of human brain. Similar to the human brain, how the internal neurons connected to each other contact means transfer information from one neuron to other neuron. In the similar way, we have in deep learning we have neural networks. In this neural networks, we have nodes. These nodes, similar to the neurons in the brain, connect with each other, and the information is transmitted between between these nodes. So, in the very first video, I have said that I have shown you a structure, right, of a basic neural network. I think this is the structure. These are nodes. Similar to the brain neurons, we have nodes in a deep learning neural network. See how these nodes are interconnected to each other. These interconnections, why these interconnections are established is the information flow will be in this way. The input data comes to this node, from this node comes to this node and flows out. We'll get the output here. So similarly, in this node, we'll get the input. Output flows through this node, and the output is given. So similar to this. In this way, the interconnections of the nodes helps in passing the information from this input to the output. So this section is completed. Now, deep learning algorithms attempt to draw similar conclusions as humans by analyzing the data. Means in deep learning, when you give an input data, how the brain processes the data that it has seen, similar to similar to the human brain, the neural network of a deep learning analyzes the data and draws conclusions from the data. Means same as the function of the brain, the neural network also functions in the same way with a given logical structure called neural networks. How all this is done, how all this interconnection and passing on information from one node to the other node is done, this is done by a neural network. So, this is the definition of deep learning. Deep learning is a subfield of artificial intelligence and machine learning that is inspired by the structure of human brain. Deep learning algorithms attempt to draw similar conclusions as humans by analyzing the data. Means deep learning algorithms are always logical, means without any logic there is no deep learning algorithm invented. So deep learning algorithms attempt to draw similar conclusions as humans by analyzing the data with a given logical structure. This is the logical structure, neural network. The logical structure is called a neural network. Okay, now let's go to the next section. Let's dive into the second section of our video. In this section, we'll be seeing machine learning versus deep learning. How machine learning is differed from deep learning. The machine learning is differed from the deep learning in this five aspects. First is data dependency, second is hardware dependency, third is training time, fourth is feature selection, and fifth is interpretability. Before going into this, let's see one topic, that is machine learning algorithms are always dependent on statistical techniques. Means machine learning is more dependent on statistics. Means if you want to master machine learning, you must be really good at statistics. But in case of deep learning, so the deep learning algorithms are more dependent on logical techniques. Means deep learning algorithms are always logical. Means let's say how a human brain draws conclusions logically, the deep learning model in the similar way draws conclusions from the data logically. But in the case of machine learning, it is more statistical. Okay, now let's see data dependency. Okay, to understand data dependency, suppose let's take an example. You have very less data. You have very less data, that is 100 rows of data. Suppose if you this 100 rows of data is given to a machine learning model, and this 100 rows of data is given to a deep learning model. You tell me which can perform better. Okay, you all might have told me that deep learning model, but machine learning model performs better on this 100 rows of data than deep learning. Means machine learning model always performs well when the data is very less in the sense sufficient amount of data is available. But when you have large amount of data, deep learning models are the best. Means deep learning model performs the best when you have large amounts of data. Okay, let's understand it through a graph. Let's say on the x-axis we have data, on the y-axis we have performance. So how the machine learning graph looks like is, you see this stability in the graph. Okay, when the data is low, you see that graph is very much exponential. Means when the data is low, your machine learning models perform really well on the data. But once the data is given more and more to a machine learning model, the performance stabilizes. Means when the less amount of data is given to the machine learning model, it performs really well. But more amount of data is given to the model, the performance stabilizes. But in case of deep learning, the graph looks like this way. Means when less amount of data is given to the deep learning model, the performance you observe is very much less when compared to the machine learning. But once you increase the size of your data, your performance surpasses the machine learning models. Means or like Zemin Asman Farak. Means the performance of the deep learning is very much larger when compared to the machine learning. You can't even compare the performance of the deep learning model when the data is very much high. Means deep learning models are always data hungry. Okay, this is data dependency. Deep learning models require less amount of data, whereas the machine learning model requires less amount of data, whereas the deep learning models require large amount of data. When there is large amount of data, deep learning models surpasses the machine learning models results. But whereas the data is limited, then machine learning models performance surpasses the deep learning model. Okay, Next is hardware dependency. Okay. Previously, most of the models were trained on CPUs. The accuracy was a bit mid-range. They used to get a mid-range performance from this CPUs. So suddenly, when the GPUs and TPUs were introduced, there started a boom in this hardware. Means in this deep learning, they started a means it really started a boom. Means suddenly the graph of deep learning was like this. Means it was going up and down, going up and down. But when the GPUs were introduced, the graph was this way. Means it never looked back. Before the algorithms were invented, when the algorithms got invented, it goes up, and when the scientists found there were flaws in the algorithms, again it comes down. Again, when the algorithms new algorithms were drawn from the old algorithms by resolving the errors, the graph used to go up. And again, suddenly when the GPUs were introduced, the deep learning never looked back. It gone very high that it never looked back. Okay. Now, hardware means CPU for training and machine learning models. CPUs are enough. Means CPUs, machine learning models train well on the CPUs. But to train this deep learning models on the CPUs was a really difficult task. So in this graph, you see that before in before the GPUs were introduced, the graph you see is very much very much ups and downs. But when suddenly the GPUs were introduced, the deep learning models have performed really well. Okay, this is hardware dependency. Means, let's say I'll give you an example. In 2012, there was a competition called ImageNet. This ImageNet competition was taken place every year, like 2010, 2011, 2012. Every year, the ImageNet competition was used to take place. ImageNet is nothing but an dataset which contains millions of images. But every year, the machine learning models used to win this competition. But suddenly in 2012, a model came into picture which is trained on GPU and is a deep learning model. This model has got an accuracy 16%, whereas the machine learning models got just, sorry, not accuracy, error rate. The error rate was 16%, but whereas the previous machine learning models which were trained on the CPU, the error rate was 28%. Means it was nearly double. Means you see that how the GPUs have brought the revolution in the deep learning. Means for training and deep learning model, you really need a very good hardware like GPUs, TPUs, and FPGAs. But whereas training a machine learning model require CPUs. Okay, let's see training time. The training time of deep learning models is really high. Means it requires some months, or it may be some days, or it may be few hours. Means training and deep learning model is a really an time taking task. But whereas a machine learning training and machine learning model takes around just few hours. Means training time of deep learning models is really high. But whereas the testing time or prediction time, let's say it's a prediction time, the prediction time for deep learning models is low when compared to the machine learning model. Machine learning models, the prediction time is sometimes low, sometimes very high. But whereas in deep learning, the prediction time is very much less. Next is feature selection. Okay, to understand this feature selection, let me explain you with an example. Let's say we have an paper which contains a raw data, which contains a raw data of quality of bricks, quality of cement, and quality of paint, and prices of those. Means Based on these three factors, the price of the house is determined in that paper. So we have several papers in that kind. Let's say quality of cement in one row, bricks, paint, price. Uh, okay, you have a paper based on these three features and the house price is predicted. Okay. In case of deep learning, what happens is when you give the paper as an input data, it automatically extracts features from this paper and it interprets whole data and predicts the whole of the price. Means you need not separately select those features individually and write down in a place and already you will have some certain house price, right? And note down the house prices and need not give it to a deep learning model. It automatically extract features from that paper and predicts the price of the house. Means the feature selection in deep learning models is automatically done, but whereas in machine learning models the feature selection is not automatically done. Means you need a separate label to determine the features, means to note down the features, the place, and train a machine learning model. But to train a deep learning model, you did not separately extract the features. It automatically extracts features from the input data that you have given and draws conclusions from that data. Means this is called representative learning. Means drawing conclusions automatically from the input data given is called representative learning. This is done in deep learning. Deep learning, the neural networks automatically extract the features from the input data, whereas in machine learning you need a separate label to extract these features. Okay, now in deep learning, let's say this is a neural network, this is our input layer, this is our let's say this is our first hidden layer, and this is our second hidden layer, and let's say this is a basic neural network. So these are the interconnections between the neural network. Let's say these are I'm drawing it very much roughly, don't mind, right? Okay, this is our input layer, these are our hidden layers, this is our output layer. I'll explain you in detail, don't worry. Just for now, remember, take it as an input layer, these two are our hidden layers, and this is an output layer. Okay, the initial hidden layers in a deep learning, in a neural network, draws primitive features. Means they are used to extract the primitive features from the data, whereas the deep hidden layers are used to extract the complex features from the data. Means let's understand with an example. Let's say I have given my face as an input. What does this initial initial hidden layer does is it extracts the data features like mouth, eyes, ears, from my face data to determine me as a human being. What does this deep hidden layer does is it extract the edges. Means edges of my eyes, edges of my mouth, edges of my ears. This is done by deep hidden layer, and these initial hidden layers extract total eyes, uh, extract a picture of eyes, extract a picture of the mouth, extract picture of the ears. But whereas this deep hidden layer extract the edges. Means this part of mouth is extracted, and this part of mouth is extracted one, this part of mouth is extracted one. In this way, the deep hidden layer extract the features. Okay, let's see interpretability. The interpretability of an deep learning model is very much low. Means interpretability of deep learning model is low and interpretability of machine learning models is high. Okay, let's see it with an example. Okay, let's say you have an Instagram page. and you have set the Instagram page in such a way that all the negative comments are disabled. Means you have bought in a deep learning. You have model. You have introduced a deep learning. Means you have a separate a model for that Instagram page so that it can automatically disable the negative comments. Means if suppose if a certain user has commented a certain comment on your image, okay, and suddenly the comment is disabled. Means if the user asks you, why did you disable my comment? Means can you answer that it is a negative? Just answer that it is negative. But if he asks you, how did you decide it is a negative comment or not? How did you decide it? But when he asks you this question, you might not have an answer. Means how did this model interpret the comment as negative or positive? Means what is happening in this neural network so that it is deciding a comment as a negative comment or a positive comment. So you can't understand it, right? So interpretability is very much low. Means you can't say what is happening in this neural network. But whereas in machine learning models, let's take this as an example. Okay, let's say W1 is the weight of this quality of cement, W2 is the weight of this bricks, W3 is the weight of the paint, quality of the paint. Okay, to calculate the output, this is the x1, this is x2, this is x3. So to calculate the price of the house, let's say we do it in this way, W1 x1, W2 x2 plus W3 x3. This is the output price. Okay. When the output of price is calculated, when a user asks you how did you determine this output, then you can say that quality of cement means W1. The value of W1 determines the quality of cement. When this weight factor is low, means quality of cement is less. W1 into x1, and W2 means quality of bricks. W2 into x2. When W2 is low, means quality of bricks is also low. W3 into x3. W3 is the quality factor of the paint. Means when these three are low, the price of the house is low automatically, right? Means when a user asks you, how did you determine the price of the houses? The quality of cement is low, the quality of bricks is low, the quality of paint is low. So automatically the price is low. Means when the quality of these three is low, automatically the price of the house is set low. Means you can explain it in this way for a machine learning model. So interpretability for deep learning models is very much less. Interpretability of machine learning models is very much high. Okay, in this section of the video, I'll be explaining you why is deep learning getting famous in this time period. Means in the like in the late 90s and 80s, why is deep learning not so famous? But now why is deep learning getting famous? Let's see first, that is data sets. Means now you have, suppose you're searching in Google search engine, you're searching something. Let's say dog, images of the dog. If you go to the images section, you'll see some millions of images. Means so much. Now in the previous early and 90s, early 80s and 90s, you don't have enough data. Means that millions of images were millions and billions of images were not available. But in the early ages, like in the 2012 and after that, you have more images, means more data is available to train a deep learning model. As we have seen in the previous section, deep learning models are data hungry. Means it require more and more amount of data. Now you have Instagram, Facebook, Snapchat, and Google, and many other let's say apps. We have to collect the images, data of the images. Means this has more data is available, deep learning is getting into a boom. Means only collecting the data is not sufficient in deep learning. Let's say suppose in your let's say you are in your first or second year. Means a baby is born, a small baby is born, let's say it has got 2 years. Means how a 2 years baby learns whether a cat whether an image is dog or a cat. Means you should have a label, right? Under the image of the dog, you should have an uh, label, dog label. Under the image of the cat, you should have cat label. So in the similar way, the collection of data is not sufficient in deep learning. You should have a labeled data. This labeled data is done by Google and Facebook, and they have Google and Microsoft, and they are bought it as an open source. Means anyone can use this labeled data and uh, can build new architectures and can make new algorithms. So now, in the early stages, data lots of amount of labeled data is available. Labeled data. This term is really important. Means as lots of amount of labeled data is available, deep learning is in a boom in this stages. Means in this early stages. And second section is computing hardware. Means in the recent times, CPUs, TPUs, GPUs, TPUs, and FPGAs. This kind of hardware is available to make the training of the deep learning models very much faster. Training and deep learning models in CPUs is very much difficult, but training and deep learning models on a GPUs or TPUs or FPGAs is very much faster, and you'll get a better accuracy. Means you have enough hardware to train a deep learning model. Means in my first video, in my second video, I said you two models, right? GPT and BERT models. This GPT and BERT models train around months on the GPUs, on the n number of GPUs, not a single GPU, or train on n number of GPUs to get the better accuracy. Means if the similar data is trained on a CPU, it may take some years. Means it may not even be possible to build those models. But now we have GPUs and TPUs and FPGAs to train those complex models. Next is frameworks. We have different frameworks like PyTorch and TensorFlow. PyTorch is used by researchers. PyTorch and TensorFlow. PyTorch is used by researchers and TensorFlow is used by industrial experts. This TensorFlow is invented by Google and this PyTorch is invented by Facebook. Most of the, let's say, most of the code in the industries is done on this TensorFlow framework, and most of the code written in the research field is done on this PyTorch. Means why TensorFlow is not used in research field is you you can't understand the code of the means code written in the TensorFlow. Means code written in the TensorFlow is not at all beginner friendly. Means a beginner deep learning engineer cannot understand the code written in TensorFlow. But whereas the PyTorch, as it is similar to Python, the code written in the PyTorch is more interpretable. Means it is a beginner friendly and easy to understand. So it is used by researchers. Means you can understand the entire flow what is happening, but in TensorFlow you can't understand the entire flow what is happening. It is done inside by the TensorFlow framework. So TensorFlow is used by industrial experts and PyTorch is used by researchers. Why these frameworks are used? These frameworks are used to uh, means better help means it helps the algorithms work very better. Means to deploy the algorithms we need frameworks. Means this frameworks helps to deploy the algorithms. Means algorithms are got into implementation with the help of these frameworks. And we have two famous frameworks, that is PyTorch and TensorFlow. PyTorch is used by researchers, TensorFlow is used by industrial experts. Next is architectures. Suppose you are building a model to classify an image, whether it's, let's say it's a dog or cat image you are trying to classify. Means building it from the scratch and determining the accuracies of one model, and you have built another model, and you have determined the accuracy of another model, you have built a third model, and you have built the accuracy, and you compare three of these accuracies and determine which model is best. So in doing this entire work is a time taking process. So, in short, what the scientists have done is they have built already some architectures. Let's say resonant. Resonant is an architecture which was initially built to classify the to help the image classification do very much well. Means it is an CNN architecture which is built to classify the images. This resonant architecture means instead of building a model from the scratch, you can already use a pre-trained model and attach it with your, means you can collaborate with your model and build an complete model to determine to classify the images. So as these architectures are trained on lots of images, you will get a better performance on your classification problem or your design problem. So, as the introduction of these architectures has become a lot and lot in ANNs, RNNs, and CNNs and transformers, the deep learning has got into a boom. Means deploying a problem on these architectures was giving you a better results. So, what people have done is, as your problem is getting solved very easily, instead of writing the code from the scratch, so they have used this architecture to solve different problems. Next is community. The deep learning community is growing like exponentially. The growth of the deep learning community is exponential. Means lots of researchers and scientists are entering into the deep learning field and are building n number of deep learning algorithms and and writing research papers. So these research papers are very much helpful for the deep learning engineers to work well on the problem statements. So this this deep learning community is increasing. The interest on the deep learning by the people is also increasing. So by these factors, by this data sets, computing hardware, frameworks, architectures, and community, by these all factors, the deep learning is getting into a boom in this time period. So I advise you to learn this deep learning in depth, understand it well, understand the algorithms in depth, and try to build a basic level projects. So this is the section on why is deep learning getting famous. Okay, let's meet in the next video. If you like the video, please like, share, and subscribe. We'll meet in the next video. Thank you.